This video is a demonstration of Spectrum Discover being used in conjunction with Spectrum Protect. What we'll show are a number of usage examples based on client questions that we've gotten to inquire about what Spectrum Discover's capabilities are and how it can be used to leverage the information of your larger systems. The first example that we have here is what is the distribution of used capacity across all of my Spectrum Protect servers? We'll start on the dashboard. And in this example, you'll see two tabs, Primary Storage Sources and IBM Spectrum Protect Sources. A primary storage source can be anything from an NFS server to Spectrum Scale to a number of other things. If we click on the tab, it'll take us to a graphic representation of the Spectrum Protect systems. Here we have three of them. If we mouse over the bar, it'll give us a summary of the used space and the free space of that particular system. This information is collected from the Spectrum Protect server whenever Spectrum Discover scans it. So this is a high-level view of the capacity usage. Now the names of these three servers on this particular panel are user-defined names. So if we take a moment and click on the admin panel, we'll show you what servers they actually connect to. And here you can see our data source connections table. On the left here, the connection names are the user-defined names, like what we saw on the dashboard. And under data source shows the name of the actual system that's connecting to. So in the case of our Spectrum Protect systems, this is the name of the Spectrum Protect servers themselves that they are connecting to. The scan status column is an indicator of whether or not that particular system was scanned successfully by Spectrum Discover. If there is an error, then an error indication will be displayed. A green check mark means a successful scan. We'll take a look at the scan history by using the Scan History button. From here you can see a table showing each item that was scanned, including its start and end time, the status of that scan, and how many records were shown in that scan. Let's return to the dashboard, and we'll return to our Spectrum Protect sources. Now we'll scroll down. And down here at the bottom we have another graph showing capacity used based on different criteria which we can establish using the drop-down menus. And we can also sort it based on the primary and Spectrum Protect sources that we have up at the top. We can do it by both, by primary sources or the Spectrum Protect sources. For example, if we wanted to see which one of our nodes are using the most capacity, we can change the capacity used by file space to node name. And then when we change this parameter, it will change the graph. And this will give us a top 10 view of nodes aggregated across all Spectrum Protect servers, not just one. Another example is breaking down on management class. And you can see a top-level view of the distribution of data across all management classes, which in this case you can see most data is distributed across the default management class. To get a more file-level count across your systems, you can use the visual search function. So to start, we'll click the search button, and this will take you to a parameters table. Most of the parameters shown here come with Spectrum Discover out of the box. However, you can also add your own parameters. For the purposes of our current example, we'll do a visual search by selecting Platform and Data Source. And so the platform will break down based on the data source type. So as you can see, we have IBM Spectrum Protect, we have NFS, SMB, and Spectrum Scale. Since we're currently only interested in Spectrum Protect, I'll click IBM Spectrum Protect, and then under Data Sources, I'll click Select All. And now we're taken to a table showing all three of our Spectrum Protect servers. And also from this table, we can see the total number of files of each Spectrum Protect server, as well as the total capacity of each Spectrum Protect server. And the files in this table are all file objects, so this could be anything from a single file to a single database. So the next question that we're going to ask here is, what type of data are we backing up? So we're going to start another visual search. We'll select Platform so that we can focus on Spectrum Protect. And this time we'll also include File Group. We'll select Spectrum Protect again. And notice on the right we have a listing of file groups. Now, the file groups are categories of file extensions. So, for example, audio could consist of any file that perhaps it could be an MP3, could be a WAV file, could be an AIFF, any number of audio files. Compressed files could be anything from zips or tars. Docs could be .doc files. They could be TXT files, notepads. And a number of these file group categories come with Spectrum Discover out of the box, but you can also create your own file group categories. So I'll go ahead and select all so that we can see the distribution across all of these categories. And this will take us to another table readout where we can see the file group distribution across all of our Spectrum Protect servers. In this example, if we sort by size, we can note that the file group which is taking up the most space falls into the other category, which is essentially any file that does not have a definition that fits into a defined file group category. Information about file groups can be found in the IBM Spectrum Discover Knowledge Center if you would like to know more. With Spectrum Discover, it's fairly easy to refine these search results on the fly. For example, if we want to see the file group distribution across each individual Spectrum Protect server, we can go to Group By and then select Data Source. And this will add an additional column called Data Source, which in this case shows the name of the Spectrum Protect server. And then we can sort the table by data source to get a clearer idea of the distribution. Let's say, for example, that we wanted to narrow in on a very specific file type and we want to see how it's distributed across our servers. For example, audio. We want to see how much audio data our Spectrum Protect servers are backing up. We'll again do a visual search, select Platform, and then File Group, and then after that we'll just select Audio. And so what this will do is it'll show us exactly how much data of a particular type is distributed across all of our Spectrum Protect servers. As a final note, using the command line on Spectrum Discover, you can customize the file groups to reflect your own company's file extensions. So for instance, if you have some sort of proprietary data format to your company, you can create a file group that will look for those file extensions. Our third question is, what are the largest files that my Spectrum Protect servers are hosting? Let's do another visual search. This time we'll select Platform and Size Range. From here we'll be given a series of size range options of size categories such as extra small, small, large, medium. We'll use this search to look for the largest possible files, so we'll select the large category. And here we have our results. So all files of the large size category we have among Spectrum Protect servers totals about 1,022 with a total usage of 11.3 terabytes. Now if we drill down one step and select Data Source, we can see how these are distributed across all of our servers. And so now once you're in this view, let's say that you want to see a more file level view, a more granular view of the file distribution across a single server. And so what you can do is you can select the individual row, then click the Convert to Individual Record mode. And this view will give you a more granular file level view. Once you're in this view, there is a filtering option. So for example, let's take the filter option and let's change the size bytes display to something a little bit easier to read. Let's change the size display to gigabytes. Now, a word on the file sizes displayed on this particular table. The sizes of the files is based on the file size attribute of the file itself. In other words, this is the size of the file before deduplication, before compression. All right, our next question is, do I have old data and how can I find it? First, let's take a moment to look at how tags work in Spectrum Discover. First, click the metadata button on the left, and then we'll click Tags. Here you can see the size range tag that we looked at earlier, but let's take a look at time since access. So these tags are essentially organizational categories that we can use for various purposes, including searching. As we mentioned previously, tags are customizable. So here under time since access, we have these 4 parameters, and each one can be named. So where it says 1 week, 1 month, 1 quarter, 1 year is a title that we can give to that parameter, and then we can specify a range that defines that new parameter. So for example, here under 1 year, we can change the range to 5 years and then change the title of that parameter to 5 years. But the title could be anything. Now, the way that this relates to Spectrum Protect is the time since access is the last time that that item was backed up on the Spectrum Protect server. Now, once again, we'll do a visual search. So this time we'll select platform, and then we'll select time since access, since we're looking for old data, and then we'll select data source so that we can filter by Spectrum Protect. And we'll select Spectrum Protect again. And for this example, let's look for data that is well beyond a year old. So we'll select 1 year plus for the oldest possible category. And then across all data sources. And we run the query, and we can see on the readout that we have data that matches that criteria on 2 of our Spectrum Protect servers. So these 2 Spectrum Protect servers are showing that they have this much data, this many files that haven't been accessed in over a year. So the way this relates to Spectrum Protect is this could possibly be data that is a very, very old version or older versions of data that have been sitting on the server for a long time. Since Spectrum Protect backs up incrementally, it leaves older versions of data back and behind. So this could be old versions of data, or another possibility is that this could be data that has not changed on the Spectrum Protect clients in a substantial period of time. Our next question is, which one of my nodes is consuming the most space? For this search, we'll select platform and then our node name category. We'll select Spectrum Protect, and then we'll select all node names since we're looking at the node name category. Begin the search. And as you can see, we have a listing of node names. And to see which node is consuming the most space, we simply sort by size. Let's take another step and refine this search by file space. So a strong administrator use of this function would be to narrow in on any possible culprit nodes that may be backing up more information than they're supposed to be doing. This is a good way of sort of zeroing in on any nodes that may be engaged in anomalous activity. For instance, in this case, we have this GTK meta node with a file space of /mnt/isilon, which is consuming quite a bit of data. So let's take a closer look at that node. Let's do another search, select platform, node name, and file group. We select IBM Spectrum Protect, and then we select the specific node which we want to examine. We'll go ahead and select all for file group. And so now, much like the search that we did before looking at file groups, we can look at the file group distribution across a specific node on a specific IBM Spectrum Protect server. So again, it's just more ways to narrow in on specific data paradigms or data patterns in your environment that you may want to analyze further. Now, how much of my backup data is inactive versus active? This time, we'll select platform and then state. From here, we can select Spectrum Protect. And then from our states, we have an active option and an inactive option. We'll select both. And if you notice, there's also an archive option, but right now we're just worried about active and inactive data. And now our readout shows that we have a distribution of active and inactive data, which is normal. And by and large, the majority of it is active data, which is also very normal. However, let's assume for the moment that this inactive portion is a little bit larger than expected. So let's take a closer look at our inactive data. Let's add the management class parameter to this search. And as we can see, most of this inactive data is inside of the default management class, which might indicate something worth investigating. So one possible use of this would be, let's say that you need to get an idea of how much space that you need to have allocated in a cloud container pool in order to tier off your inactive data. You can look right in here to see exactly how much inactive data that you have so that you can properly set up that cloud container. The next question is, how can I map the standard Spectrum Protect or Spectrum Discover data against my own organizational constructs or tags? So another function that you can perform is you can create your own tags and customize them. So let's say that you want to tag data that belongs to a specific project. So what we're going to do is we're going to create a new organizational tag, and we're going to give those tags to a group. And that group is going to be called project. Now, this will become one of the search categories that we'll be able to use in a visual search later on. From here, you can assign a series of tags to belong to the group. The three types of tags that you can create are open, meaning any value, or you can have restricted or characteristic values. We're going to set our type to restricted. This will allow us to control whatever tags are included in this group. And then from here, we'll create a series of tags. We'll say finance, HR, and DevOps. So these are the only tags that will apply to this group. And now we have our new project tag group with the three potential values. Now that we've created our tags, let's start actually using it. We'll go back to doing a visual search, and we'll select platform and node name. We'll select Spectrum Protect and all node names. So let's take 3 of our Spectrum Protect nodes, and we're going to tag them with the DevOps tag. We'll click Add Tags, and then we select our project group, and then we select the DevOps tag. And so now, what this will do is this will create an implicit policy. And now this policy will run in the background and will tag that information in the Spectrum Discover catalog. So now, if we want these items to be reflected in our search, we need to perform a catalog refresh. And normally this takes a significant amount of time. However, we can simply fast forward. So inside the Discover database, there's this metadata summarization database option. So click Run Table Refresh. So once the table refresh is done, we return to our visual search, and this time you can see that we have the project group available. So we select project, and there we can see our DevOps tag. Select that. And there we can see the total number of files and the size of the files that match the DevOps tag. And so this is an example of how to apply custom tags. Our second to last question is, when did I last back up a particular file? When did I last back up file X, Y, or Z? We're going to return to the search panel. However, instead of a visual search, this time we're going to do an ad hoc search. We use the search field at the top of the page, file name equals, and then in single quotes, type a file with a file extension, and then click search. And in this instance, you can see we have several copies of this particular file, all on our Asana Spectrum Protect server, spread across several directories. And so let's say that, for example, you have a file that may be suspected of having something wrong with it. Perhaps it may be corrupted or have some malware into it. This would be a reasonable way to narrow in on that file and find out exactly where it's located so that you could take surgical steps to remove it from the system. And now our final question is, how is my data distributed across my tape libraries? So the first step is to use the command line to access our Spectrum Discover server. So we're going to secure shell and access our Spectrum Discover server. Now from here, there is a reports directory, which we will go ahead and access. And the essence of answering this question is to show how to create custom reports. And we'll be doing this from the command line. Spectrum Discover comes with a number of reports that it can send to you. But what we're going to do here is generate our own by issuing a SQL script. So here what we have is a query which we can view and run, but more importantly, we can create our own scripts and run them. So now to run this, Spectrum Discover has a generate report script. For this example, we're going to tell the report to generate a tape.csv file. The username is the administrator username for Spectrum Discover, which in our case is just sdadmin. And we want to generate this report using our tape.sql query. We'll get a password prompt. The Spectrum Discover Knowledge Center has this process well documented if you'd like to know more information. And here we have our example report, which we'll open up in Excel. And you can see that this is broken down by node name. And here we have a column called MIGLOC, or migration location. So this is the destination of the tape libraries where the items are being migrated to. And in the last two columns, we have an object count, and then we also have an aggregate size readout. And so to wrap things up, this readout most likely is a combination of virtual tape libraries and true tape libraries. As you can see with the top items directory locations are indicative of probably virtualized tape, and then the items starting with RN are probably real tape libraries. But the point is that this is how the readout will look like when you're looking for your tape library distribution. In any case, thank you very much for your time. Thanks also goes to TJ Harris and Trisha Jung to make this video. Have a good day.